Good afternoon, everyone. Today we have our speaker, Mr. Maunesh Marali, for the topic Industrial Analytics and AI Suites Enabled by Cognitive Data Lake and Data Models.
Yeah,
Mr. Maunesh Marali is the Global R&D and Technology Manager, currently heading DCS Service R&D in ABB Industrial Automation Division. Mr. Maunesh has 25 years of industrial experience in business R&D, technology management, product and portfolio management, engineering and software products, advanced digital services development and digital transformation. Also worked extensively in system engineering and process control application development, system commissioning, process stabilization and optimization. This includes complete end customer site acceptances for various industrial automation projects based on DCS, PLC, SCADA and drives serving for various industry segments such as oil and gas, power generation, petrochemicals, fertilizers, steel and cement industries. He is an expert in hardcore embedded application development on RTOS and Unix platform for robotics and motion control, includes multi-axis high-precision motor control applications on generic controller-based robotics and material handling systems. Mr. Monish has obtained his Bachelor of Engineering degree in ECE from Gulbarga University and Executive MBA from IIM Bangalore. We welcome you, sir.
thank you very much for the introduction. And today I would like to introduce the ABB's Industrial Analytics platform and AI suites, and also a little bit cover on the cognitive data models and industrial cognitive models in a way. And more from the industry application standpoint, especially process industries and industrial automations, where we have several control system and allied equipments as well as the sensors. So how an industry needs to move towards the process excellences while integrating assets and enhancing the productivity of different assets who are contributing into the process plant operations. So how this artificial intelligence and supported by the data models and industry specific data models, how that helps in these perspectives. I'll try and attempt to cover these topics. Little bit looking from the industry standpoint, what we are in ABB is providing a comprehensive value-added digital offerings, and then that needs all that customer perspectives, and that is very important to the time of the situation for industry where they're evolving. And then we would like to also leverage our industrial automation domain expertise, and which comes from different process application, be it oil and gas, pulp and paper, and various other things. And this is combined with superior analytics and AI modules, and we are combining those capabilities to offer these. And also we are providing the modular infrastructures, be it ABB hosted cloud or customer subscribed cloud, or in fact the on-premise solutions. So looking at this and what is that the value we are providing basically from the overall industry origin standpoint. And ABB is focused on different asset, the platforms, which is basically the smart equipments providing the on the digitized platform, which includes various process equipments. It includes safety, security, and performance, and asset integrity, and so on and so forth. So some of the examples we can take that our marine and port process segment, where we have Agiport, which is creating the trust profiler for the large ships, and also the assets and devices, which gets millions of devices, which gets into process industries, which could be flow, pressure, temperature, name it, any process parameters, which is basically important from the smart equipment standpoint, and also covering the turbochargers is another business division, which is basically quite significant from the process point of view. Totally, if you look at, we have today 7 million devices, 7 million assets, in fact, and our devices could be part of the assets, and there are 7 million assets worldwide, which is basically we are moving towards the smart equipment service providers. And then the digital value drivers from our solution offering standpoint, we have plethora of different applications concentrating main on the industrial automation domain, categorizing into 5 different categories. Basically, if any industry, basically from the process point of view, could be process performance excellence and asset integrity and the sustainability and the safety, and also supply chain integrations and providing energy optimization and reliability in the process plant operations. So our values from the digital point of view, we have currently 30 plus applications. This continues to grow in the AI suits. And then where we will be going towards is a comprehensive and integrated digital suites, and that's basically is our ABB's platform, what is today offering, and that is basically the providing the intelligent approaches enabled by the AI ML models. When we are talking about those things in a time from now, and then the having the deeper industry cross-function insights and collating the different information through different source data, and coming up with the cognitive models for the very industry specific applications, and also building various models and deploying those without any expertise from the customer side. So that is basically what we are looking to achieve in the value chain. This is a little bit of complex diagram, but even though I try to explain the bit, um, in the top today we have our customer segment. That means our end users, whether the customers are oil and gas, or maybe chemical refining or power generation, or it could be minerals and mines and robotics and marine and ship, any customer segment in the top. And we want to provide an IA digital portfolio. IA means industrial automations, where we have 3 categories of the digital services, which gets into the smart equipment and the digital assets, and also the digital value drivers, which is basically what we talked about, those 5 families, the like process optimizations and asset integration, safety, and so on and so forth. And the comprehensive and integrated digital suites, which is basically enabling to provide the smart solution to the end customers. So then our infrastructure, this is a core of the entire solution offering. It's basically comes from our the smart monitors and the models, which is basically driving all that data connectors and adapters, bringing the data into our edge computing platform called Edge Genius, where we have our OT and IT, and also engineering data, more preferably OT and ET data from when it comes to edge computing, and also the below that we have our control systems, primarily distributed control systems, SCADA, and other subsystems. All the data gets into edge computing, and that platform enables the connectivity to the upside into our cloud computing, and that's basically our Genix platform. Namely, you can see that the data which is coming from OT, IT, and ET, what we call it as a fusion hub, and then it will get into an industrial system information model, because we need to map from the metadata and from the different data itself. We are going to structure it, then we are going to contextualize those things, and then we are deploying onto AI ML model in our suite, and then there will be exploration of data and different models through our analytics and application studio, which we talk about, and then the providing the capabilities to self-service analytics. That's basically we are leveraging these technologies without much of a domain expertise from the customer side. That means the key is the AVB domain and the expertise which gets into these analytics. And below we have a customer cloud, and either we can we can host in the customer cloud, or we can host onto the ABB hosted cloud, or on-premise. All this solution is possible, and which is completely provided by our asset stream in the below. And if you look at the industry, today's situation, it is a huge market opportunity. And if you look at the curve, the red bubble shows that where the digital services are having uh, potential market opportunities, and these red bubbles very specifically talk about our market specific, demands which we are currently working on, and then you will also see that different numbers. So overall, if you look at more than 72 billion industrial automation, service from the digital enabled applications which are provided on the AI market. So we are seeing this much progress going forward. And little bit, if you look at the origin of customer maturity perspective, how the values are driven, when you look at the industry platform, basically that the value proposition comes from the type of customers and their platform itself. Customer have better clarity on their needs to optimize the operation and asset loops. That means different assets that contributing into the plant operations. And then they will also have enterprise systems, and also having the safety and reliability and the quality standpoint. Finally, adding the value engineering for the digital twin kind of applications. So if you see in this plot, and the functional, cross-functional, and integrated enterprises, if you divide these things, which is basically we can categorize the first thing for the functional needs, the information and connectivity is quite important, and these kind of customers are we can categorize like beginners, and a little bit matured customers, like we can call it intermediate, and there they want to see the visibility what's happening, and also the transparency that how why it has happened, that and how I can understand the root causes and that kind of things. And then the advanced kind of customers, they are looking for predictability, like this particular asset or equipment is going to fail 10 days from now. Already I need to know the what's going to happen, so that the prescriptive actions can be initiated to fix those things. So this is basically demanding more and more. The maturity is growing over a period of time, and that is where is all our technologies are enabling those now. So what are our customer needs? I'm a little bit looking from the industry, in the industrial automation business standpoint, from our different customers worldwide. So what they want to see is increased availability of assets and their plant, so that they can avoid the unplanned disturbances and shutdowns where they are losing a lot of productions. So how can they do proper anomaly detection, be it asset or a sensor or its network, or it could be any processing equipment, it could be operation itself overall. And then how can they minimize the production loss? If there is an incident happening, how can they minimize the production loss, so that they can build applications, solutions with high quality, and they are equipped to provide the better yielding capabilities there. And then the optimizing performance of the heat and fluid transfer equipment. It's basically, the there are several process equipment, be it reactors, heat exchange equipments. It could be pump, a reactor. There could be many process equipment that basically providing the maintenance strategy, how they can reduce the cost of the maintenance and then still see the reliability, and then their life cycle forecasting, how long this equipment can provide with healthy performance and these kind of things. And then the asset integrity is basically looking 360-degree perspective of an asset, and basically using digital twin capabilities, how the cognitive industry data models are enabling these kind of the visibilities in the enterprise level, not just from the OT, but also gathering the information from the IT, like CMMS, the computerized maintenance and management system, and Maximo, SAP, be it anything, and then your design and engineering parameters coming from your ET systems. So put together hierarchy of this data and coming up with the structured information model can provide the 360-degree, or you can call a 2D or 3D modeling of that particular equipment, and you can see some examples in my sessions later. And then the operational management and asset integrity assurance, that is one of the key in the large process plants, and they would like to have excellencies from their operations. This is only contributed by healthy assets. How can they predict it? And that's basically the deploying the real-time and predictive analytics capabilities and managing those things. And self-service advanced analytics, which is also like our Fusion Hub and also our Fabric as part of our AI platform, supported by different data models coming from our metadata or a heterogeneous data which comes from the time series or MTTQ from the real-time applications. So we will have these platforms and the pre-built applications that anyone can explore the data and then build the possible models and register those models and then use it for different applications in industry platform. Integrated manufacturing and operational excellence is the one thing which is basically catching up more and more from industry 4.0, from the industry IoT standpoint, where they would like to see everything integrated from one plant to another plant and one system to suites of the systems and even the products connected and network to the entire production system. So these possibilities are going to provide what our customer needs are. So we will see a bit of those things in the coming slide. So in a way, what we are saying here, we are providing, moving on the value chain, connecting and providing condition monitoring and the predictive maintenance of an asset, and then also managing the performance, and then finally going towards APM 4.0. It's part of Industry 4.0, and then going with the customer value chain. Having all this said, then what is this current situation today? If you look at the industry standard, 40% of the productivity gain is already provided by the AI integration capabilities and worldwide if you look at it. But then the 73% of data from the enterprise or OT or ET, they're not used. That means that it's a huge potential. There is a beginner and intermediate kind of industry platforms are not exploring those yet. So that gives the clear potential indication that the AI capabilities can explore. And then the 80% of effort spent on the data today is basically for collection and injection and contextualizing. So that means the 20% of the effort only goes into the analytics part. But then 80% of the effort still goes into collecting the data, whether it is from OT systems or IT systems, namely your SAP or CMMS, Maximo, any other things. And then the engineering and design perspective, if you consider these kind of data, which is a very, very significant part of an effort in the advanced analytics from the AI-enabled systems. So we will see the sum of those things, but this is basically the trend what we are seeing today. So which is what is we need to accelerate and mature towards our digital transformation journey. And that means that we need to enable the industrial IoT and the soft sensor through data discovery, integrity, and governance with the secured and reliable approaches. and then integrating or converging, sort to say that our operational technologies and IT, information technology and engineering technology, all these things should come to the foundation of Industry 4.0. And otherwise, it is not possible to see a digital twin or asset integrity, as briefly mentioned earlier. So then building different models. So this must have a capability to self-build the model and explore the model based on the available data and correlating data and contextualizing the data, and then how we can also build that industry-specific cognitive models, and that is very, very important. I mean, many people can talk about. So we have a lot of data, and we can build AI, ML models, and we can explore, but that is not sustainable approach. So that's basically the model creation, and seeing from the comprehensive perspective is very, very important from the industry platform. Analyzing the prescriptive and descriptive data, and also coming up with sort of intelligence towards the predictive analytics, which is of course enabled by AI, and then the ML models. We'll also talk about those capabilities, and then finally deliver the capabilities for the different ABB, also the third-party components, which is what is we're currently working towards the customer needs. So now let's look at the technology point of view, and it's completely a fragmented solutions. It's like a plethora of so many solution providers, technology providers. How will you expect customer to integrate these things? Isn't it quite complex? I think one can go and try to explore these technologies and try to integrate, provide valuable solution, but maintaining and upgrading and moving on the value chain is going to be the hectic job, because customers or end users is not an expert to provide all the solution. So which is what the industry platform needs, a sort of partners, and the AI and digital analytics suits needed to be providing very reliable services by integrating this complex structure, the fragmented solution, what we see in the market. So in a way, if you see the integration of these things, it's mind blogging. Like, one cannot expect that how consistently you can keep these integrated solutions and the technologies together and upgrade. It is a heck of a job. So maintaining this definitely a challenging stuff. So that is where is the today's industry challenges. Many the potential needs from end users are not successfully going through, or maybe the platform providers like ABB is very much important. So what are the challenges we are seeing today? The customers are looking for operational risks. Customers are looking for how they can remove the silos from the information and structure that, and then how can they integrate the supply chain, and how can they do asset integrity, and then how can they reduce the plant maintenance effort, and also the cost of unplanned shutdown and things like that. And then moving towards the operational excellency while sustaining the improvements what they're achieving. Therefore, ABB comes up with providing its integrated solutions towards the operational performance management and asset integrity and sustainability, and also the supply chain integrity and efficiency providing. So how are we doing? It's basically having the left part. This is basically our completely AI analytics, which is basically provided by converging and collation of these three different data sources, basically IT, OT, ET, and then contextualizing different data, whether it is metadata, or whether it is heterogeneous data, or it could be time series, or it could be real-time MTTQ kind of approaches adapted. And also coming from our IT, we will have different enterprise systems and how we are going to collect those things. So then applying our core competency, that is a domain expertise, and building these cognitive data storages, and also building the pre-built applications using the cognitive industry-specific models, and then offering these solutions. Um, what is that unlocking the opportunities? What are the components which are key? It's basically the data. What I told, 80% of effort goes in contextualizing and bringing the data and applying different business rules and filtering. All that goes from different data sources. And then the domain and technology. When it comes to offering this AI solution, one is the data. That's very, very important, super most important. But then understanding this data is also another important. How that would come, it's basically comes from the domain knowledge, which is basically specific to our own technologies. And then the capabilities, providing the whether the entire platform or it is hybrid approaches of existing ABB hosted or maybe the customer hosted, all that is possible through providing these capabilities. And then if you look at the pyramid and you see this, all that data flow, and then consolidating the analytics platform, it is basically the sensors and transducers and actuators, which are all coming from the field itself. And the real-time control systems, traditionally they are controlling and operating those. And then the situational awareness is already today in the traditional control system platform partially providing, but then what we don't have is autonomy or self analytics, or maybe the predictive ability is missing here. So that's what few parameters I was mentioning earlier. So that's where is we need to have a performance improvement, providing the predictable and prospective analysis with an enterprise ratings. So that means it doesn't only one kind of roles. It needs the different levels. It could be at a field level, the supervisors. It could be functional users, or it could be administrators who are managing this functionality, and also expertise and the specialist, and also executive management. They will have an overview of what is going to happen. So that means we definitely need to provide the enterprise scale solution, providing the operation and asset reliability, and so on and so forth. So this empowering diverse roles to get both deeper, both in the vertical and horizontal perspectives, and then we also needed to provide the with diversified ecosystems where everybody can see in the transparent way. So the convergence is also a very important aspect that is coming up more and more in industry today. It is not an IT or OT working in silos, or also ET. Basically, they need to be converged, and we need to see the information in totality. So with a secured approaches. So which is what is our analytics platform. Basically, if you look at in the left side, we have data sources, various data sources, which is kind of sensor data, operational technology. That's basically our distributed control system, traditionally SCADA and subsystems and so forth, and our IT systems. It could be ERP, it could be CRM, it could be CMMS, or it could be learning information management, many things. It could be in engineering information systems, and also geo information systems, and also social enterprise systems. All this is possible in an enterprise when they're managing this kind of industrial automation activities. So that source is fed into the our contextual fusion hub. That's basically item number 1 2, where we have an omni solution integration platform, which is basically going to provide the different data contextualization capabilities. And EdgeGenius and OT Edge is our edge platform, which is basically building different data adapters, which can pull the data from the source systems, what I'm talked about in the left side. And then the another parallel component is a system digital twin, which is basically manifesting the physical entity of the asset component, creating virtually in our AI suits. So that means you can see 2D, 3D modeling of the particular asset entity, and then you can see that how the services can be provided, how to identify the syndrome with that particular equipment, and where the problem is existing, why the problem has happened, and by when this is going to be, coming across catastrophic failure. and then what kind of remedies, kind of prescriptive actions should be provided. All that is possible with the digital twin in this case. So now the coming to the third part, and that's basically the pre-built extensible industry standard system information model, which is basically divided into cognitive data lakes and also industry cognitive models. So what do you mean by cognitive data lakes? It's basically like we are kind of consolidating the data after the ingestion, and we are contextualizing and we are filling those with different structures and informations. And then the industry cognitive model, it comes up with the pre-built models for different industry applications and also different categories, whether it is asset or operations, or it is management of maintenance and repair, or it is health and safety, could be anything. So you will see all that pre-built models available. And then the fourth one is the analytics application studio, where we can see these various types of app building capabilities. And then Model Fabric offers basically kind of sandbox where you will see the AI ML models, where we can extract the data from the data lake or cognitive models, and then you can explore the data and you can build the model and you can register the model, and then you can extend this for the deployment. And the knowledge service app basically helps to build the knowledge which is acquired over the period of time, and also extending this for visualizations and also rebuilding of those models. And the fifth part shows the value driver applications. You will see the abundant amount of the knowledge which comes from the platform, which is basically providing the pre-built applications for different business requirements. So one who wants to explore the and also utilize this advanced analytics capabilities, he don't have to start from the scratch. He can always explore the existing app stores, and then he can build what he wants to apply these capabilities. And then the asset integrity and the digital twin we were a little bit talked about to build the 360-degree perspectives, and the predictive analysis is possible on that. And then executive dashboards and reporting capabilities provides for the third-party components, how you want to represent, how you want to analyze the data, how you want to create the reports, and how you want to notify the different subscribers. All that is possible. Finally, the sixth component is the operational excellency. We want to provide what I talked about in the initial remarks. Basically, the operational performance management and industry operational excellences, or enterprise safety and sustainability, while keeping these performance up to the mark, and the asset integrity, and also integrating CRMs. Um, I'm a little bit trying to take each components, and basically it gives some understanding that how a typical AI platform and suits performs. The one part which we little bit already looked into, the connectivity, and I mentioned the 80% of the effort in the advanced analytics goes into data injection and gathering from the source system. So we have these components basically provides different industry specific connectivities, which pulls the data and then contextualizes, and also applies the different the filters there. So it could be OT and IT and then the ET, all the data coming from the source systems. And then also have wide augmented of pre-built adapters, which is basically different data source or protocols, we will see in the coming slide. And then this edge component I talked about, it is already providing the computing capabilities, which we have the the Docker containerized capabilities on the edge components, and it is basically providing these the adapters which are augmenting the different data needs, and also different capabilities, which is basically like data could be of time series data, it is high volume data, it could be real-time data. Everything comes from these adapter provided capabilities. If you look at the control systems today, or our domain, how these edge computing components are interacting with our source systems, mainly I'm talking about OT, IT, and ET below. They are various connected assets. And then the edge component at Edge Genius, which is basically pushing the data to the cloud. So these clouds are ABB hosted clouds, which could be also like customer subscribes portal in the middle portion if you look at it, or it could coexisting of ABB and the customer subscribe portal, and then they are interlinked with that, or it is possible also to deploy these AI suites on the on-premise solutions, which is not necessary the subscribed cloud, but it can also execute can be executed on the customer's on-premise components. And then we are talking about the different pre-built pluggables from the data connectors. So when we talk about business IT and asset from the OT standpoint and IT standpoint, your different asset management systems or business IT systems, and we don't have to scratch our head, and it is already built, and you can just need to deploy those connectors, and this is ready for extracting. And then we also operational technologies. It's really coming from the runtime systems where the enterprise spy or OSI 5, you might be already aware of this, and OPC UA, OPC DA, and also very ABB specific systems. And also the telemetry data coming from ABB ability itself. These adapters are possible to get it from. And then we also have some data which are basically engineering specific and design oriented information, whether it is big data or it is basically heterogeneous geospatial data, which is basically required for orchestrating or even at the enterprise level, manifesting the services which really looks like the physical components. So that is basically important from the synthesis point of view. Um, the basically the system digital twin, as I little bit talked about earlier, it provides the accurate information of the physical component in the virtual mode, and then you will also have a different level, different hierarchy of the data, or not the hierarchy, also coming from different sources, and then it is basically filling those information model structure where this enables building the component view which is existing exactly in the field. For example, I see a reactor in the process plant or in a chemical plant. I want to see the reactors in my virtual imagination, and then how this reactor is basically operated. It has got motor, it has got a fan, it has got inlet outlet valve, and it has got a catalytic components which is fed into. It has got a temperature and pressure and a flow measurement. You just see that how many process parameter needs to be calculated and then monitor for it is anomalies detections. So all that could be seen in 3D perspectives. So that is really complex. If anyone wants to see that, the process plant is somewhere in Neyveli lignite plant in the power generation plant in Tamil Nadu. So you are sitting in Bangalore, you want to see that how the process plant of power generation is happening, how the turbine health is monitored. So it is very difficult for someone to imagine by sitting here just by reading those parameters. But then if you are constructing the actually the turbine of that plant in your virtual application, and then you will see all the parameters which are physically connected and operated, which you can see that what's the problem. That is something like wow. So you can really manifest that. So that is basically the twin capabilities are providing here. So what is the purpose we want to have this digital twin? Is basically, if you look at the enterprise plant architecture in a pyramid structure. It is basically equipment and the sub equipment below, and then we are also constructing by location and different hierarchy and the structures. And it is very much important to create those the perspectives, whether it is 2D or 3D, and you will be able to see those kind of visualizations. What are the key features? These basically like default asset class templates, which is possible now. You have JSON templates mainly used for all these template constructions, where you want to have a component called X, then you have already template available, and then it is very much aligned with this ISO 15926 compliances, and then the configuration quickly for the different data source, and also tag information which is coming from the real field sensors, because when you see a component called reactor or a pump, and it will be different sensors associated with their controls, and we need to also assemble those signals. So that is very important for quick configuration. And also most cases it comes with the free configurations, because we understand, because it is our domain expertise and our own technologies, we can surely do that in a less amount of time. And then the key features, if you a little bit extend that, basically unifying the data from different sources and contextualizing those from the IT, OT, ET, and then following some standards, and then also putting this asset data integrity. When we are constructing a pump or motor or reactors, and you need to associate different data. That's what I told about. And then the sensor informations, that whether it is a pressure transmitters or flow transmitters, or it is a um, limit switch, or it could be any sensor. So that sensor informations which are built onto that component in the real field, those signals must be associated. That means it is really important. One should take cognizance that how important these features are. So then hierarchically, you can also link with the SAP and basically Maximo or enterprise systems for maintenance and monitoring capabilities. That means you can link to the commercials, and when this equipment is brought, what is the life cycle status, how much cost it was, what was the maintenance forecast. Everything you can see the cost benefit analysis when we are analyzing the life of the system. And then we will have several APIs and the data viewers on that. And a little bit going into the cognitive data lakes, and it is very important. As part of this, I wanted to cover the basically the overview of this data lake itself, and how the data is streamed by running the batch and on the continuous pipelines, and then how you can ingress the data streams, and then also the processing the pipeline um, when we are acquiring this data. Um, and also we a little bit look into the industry cognitive model, and how we'll see this common and specific data models which are basically used in the industry specific application building. So the cognitive data lake is basically constitutes the raw data store, which is coming from different sources of categories and different catalogs and different sensor tags, etc. So the transient data store for cleansing and also the contextualizing also happens. We'll see in the next steps. Curated data is stored and it is contextualized, and then it is also used for analytic explorations. And then it is also connected to the sandbox, where we will apply our model fabric to explore the model buildings, and also look at that how that can be registered. If you look at that, cognitive data lake is provided, whatever data comes from our edge component, what we have explained a little bit earlier, that data goes into the raw store, which is basically storing that all the data which we are not going to delete, it would be there for long period of time. And then in the next step is it goes into transient stage, where it is contextualized, and it is also a little bit processed here. And then it is also curated, like your hot, cold, and warm data. Basically, what do you mean by those things? Basically the data which is basically used for the latest period, which is can be called as hot, and the warm is something like it is intermediate, like it is 3 to 5 years of origin. And then if it is cold data, it is not probably used that much extensive. That kind of categorized data could be curated and stored there. And then this transient stage, once the curation happens, contextualization happens, probably that would be deleted, but not from the raw store. And then the industry analytics store is basically pulling those curated data models into further analysis, and also using our sandbox for explorations and also model creations. A little bit about the process flow and how the different the workflow helps from adapter to Bob publishing, and then it goes to the landing blob, and then it gets into data lake, and then industry cognitive model staging, which is also coming from all the ADF formats, and that's how the entire the filling of the data into these models takes place. I will not go into the details because it is too much of a detail for this session. Um, and then if you look at the cognitive model, and if you look at the overview and data sources, basically coming from two different approaches in the batch data processing and also real-time data. The real-time data goes from the message broker, something like MTTQ, and then the different streaming data streaming pipes, which are basically contextualizing and also giving a different windows of series of data to aid the contextualizing process here. And basically this gets into time series DB, and then it will also be pushed into cognitive models, and then the data is created here, and then it is also given back to the ray data, which is basically coming from the batch processing together from the ray data, and also the created or contextualized data is processed by this batch processing capabilities. If you look at the right side, we have various APIs for a different application purpose for dashboards and the reports, and we will have an APIs, and then we will also have contextual data, which is used for especially AI and ML model for model exploration, and then the data lake raw data is also used for further explorations when we're building models. So if you can summarize this, and the stream data process is basically used for different windows, and it is basically the serialized different batches, and then also the micro batches and tumbling windows provides this data flow. It's provided by our pre-built connector platforms, which are basically MQ connector or storage connector or a crypto APIs with all the secured approaches inbuilt. And the contextual curated process will also have the contextualization process itself inbuilt into this while it is doing, and then it is periodically the tag to hot and warm and cold kind of categories. That's basically happens in the contextual and curated process. So unified view of this hot, warm, and cold perspectives are seen in a different data types before it is sandboxed for the model building. Coming to this cognitive models, and what is that we are going to inspiring from this? It's basically the cross-functional deeper insights into our own the customer or industry application models. It could be oil and gas, pulp and paper, marine, and so on and so forth. So that is basically comes with a pre-built rich cognitive models already available in the suite. And then we'll also have multidimensional data models, and the online analytical extendability frameworks are also available there. And then it is compliant with the standards like ISA 95, and also it is defines the ready to use analytical models. That's what I was telling earlier, so you don't have to scratch your head from the beginning. And then the self-service through extensive data elements and the business context. That means that you can use to self-build your analytical different analytical capabilities, so that you don't need to be a scientist as such from the scratch analysis. Those kind of capabilities are possible in this. So that basically this indicates here that different cognitive models, which is very hard to see here, but not to be going in details, but I will show in the next slides. how this industry cognitive models looks like. And we have the common entities across the value pillars. That means that we have different business applications, so you don't have to be specifying per specific things, but these are all common things can be applied. And then we have the different industry specific applications, be it oil and gas, refineries, petrochemicals, both from vertical perspective and also operational perspective. We can use these models already pre-built. And the below, if you see the different value pillars, we talked about the 5 value pillars. That is basically operational excellency, asset integrity, environment and safety, and business and supply chain. All these solutions towards these value pairs are basically provided by pre-built models in these cabinets. And on the top, you have a core apps, and it basically provides the standard models for the business analysis, like opportunity loss manager, system AD, or machine performance analysis, or very specific view applications. All that can be built in by using these cognitive models from the specific industries perspectives. So if we can look at a little bit, they provide multi-tenant supports, and also provides the localization and internalization of um, the data model itself. And they have a master data management support, which comes with a multi-score integration, and also source and standard attributes are associated with that. And also you can do a cross references with many entities with these models. Um, Going forward, if you can little bit look into the schema of such models, and basically you can analyze the different dimensions of the parameters. Let's say now I want to analyze the cost parameters, that schema capabilities, whether you can roll up or drill down, and you can go to the any dicing level, you should be able to extend this. If you look at the right side picture, and I would like to see the and analyze the cost factors from the equipment maintenance standpoint. What is this labor cost, and how the health was spent so much money, and organizational point of view, where it was belongs to, and many things. You can go with the equipment and material, and time origin, organizational origin, and also functionality point of view. All that could be possible with these cognitive approaches. Coming to this, the model fabric, it is basically an important part of our service providing. This basically first component is Analytics App Studio, which provides the capabilities for business IT and domain expertise to build and configure and package the value pairs in the analytical applications. And the model fabric, as I was already talking about, it's an environment for the domain specialist or the data scientist to explore the data, and also build and train the analytical models, and manage, register, and deploy it, or maybe you register it for your own model for the next set of services you're looking for. And then the knowledge service hub provides the different services, which is enabled by REST application interfaces, which can be used for visualization or dashboard, or maybe third-party integrations. Model fabric, if you look at a little bit more and how the data exploration and model recommendation and registrations, it's basically like any model building capabilities. Like, when you know the data and you're going to explore, before explore, and our capabilities already provide the contextualization and also rating those. And then you will also be seeing the heterogeneous perspective from the different data, and also even model itself. And then you are going to build that, and you are going to run using the sandbox. And that means when you're building your own algorithms, you need to also test it. That's what the sandbox provides there. And then once you are satisfied, and you're going to create that as a model and register that, and then you will keep it in the store, and then you deploy for the specific solution you're going to be. And then the model fabric offers exploration as well as model recommendations. And what are the steps involves? Very high level. If you look at the data ingestion, what you're seeing, that data validations, and then the data cleaning, And then the future engineering, basically like associating different parameters from the design perspectives, and then the model building and pipeline creations. So these are the things that's built in part of that. And if you look at the model fabric, and I'm just capturing a bit of different algorithms when you're running from the whether it is classification or clustering, and you will have a different algorithms, and you can select, and then you can see the actual data for the different algorithms, how the performance you can see that. And the same could be seen in the decision tree analysis for the different algorithms. So a little bit about looking at how we are building these models. Basically, like we use the model training from the from the explanation what I had earlier, and then you will basically upload the the trained model, that is PKL model, and then you'll have the data coming from the field, that is like a JSON file, and then you'll upload the file into the our AI suits, and then you are going to see the input JSON, which is basically coming from the model itself or directly coming from the field, and then you will have the scoring scripts running, and then you're fetching the mapping JSON and configuration JSON, and also trained model to provide the output JSON. If you look at one example that what we have specific industry business problems, that you have a large ships and you have a propulsion system where we call it is propulsion is provided by specialized technology from ABB. It's called Agiport motor propulsion, and we would like to analyze how that motor health is kept constant, constantly monitored for any kind of catastrophic failures. If you look at some of the parameters that the AI suit is going to analyze for the data what we are getting, like motor power, torque, and speed, and the different temperature for different windings, and then the temperature for inlet and outlet, all that data is available, and how we would build the model for this. For example, you have the data which are contextualized, and then you are basically considering these parameters here, and once the model is built, and then you are going to also see the residual generations which are coming from the domain itself, and then you are going to create by running the model and some sort of alerts, and then if you look at that perspective, different models are fed into this, and then basically the winding temperature of each motor using the data when the system is deemed normal and healthy. That means we built a model with the different temperatures and in a healthy system, and then you are going to run for the actual data, which is basically the asset is in running, or this Agiport is in running. So then what you're going to see is that the analytic suits are basically looking for some anomaly in this. That's basically like, the start and end. If you look at the one particular period, and some anomalies occurred, and that was there for a particular period of time. And then if you look at this analysis part, if you look at with some threshold applied for those fluctuations, and there was anomaly detected which was exceeding the threshold, and the alarm was raised. Before it gets into catastrophic, and already the lead time provided by the system, look, and you have this time t, and you need to act something before the catastrophic failure happens. So this kind of predictable and the prescriptive capabilities comes from this analytics platform. Knowledge Service Hub, and as I mentioned, that it is basically provides the self-services and for further analysis and integration with the third-party systems. So I will not go into the much details into this. Simply to say this, how our cognitive models are basically exposing the data. So the Knowledge Hub provides the information which are basically interconnected with the different components, and the data is explored to the Power BI kind of applications if you really want to analyze, and also from third-party tools, you can definitely use this knowledge of services for your own analysis. The dashboard is basically, dashboard is another important point, and how you provide the visualization of these analytics. and we have provided a dashboard platform. It is common HMI, where you can build your own visualization capabilities using the data of different categories with our connectors and APIs. And then the metadata layer provides the capabilities that you want to use, what capabilities of the dashboard you're going to use it, whether it is chatting, aggregation, calculations, anything. So, and then you will be building your own widget or a dashboard for KPI monitoring. So all that is provided by platform, and then it is application security and authentication is quietly built built into the system itself. The Digital App Center provides the comprehensive application management capabilities for self-service, and then asset integrity you already talked about. It is basically like building those structured and categorized and rationalized view for the asset integrity and analytics for 360 viewpoint. And then we also have the capabilities for continuous performance monitoring and integrity and sustainability is all possible with these kind of applications available in it. Finally, that we are going to reach the 5 value pairs with these capabilities like industry operational excellency, operational performance management, and asset integrity, and enterprise safety and sustainability, and supply chain. These are all basically, maybe you don't have to get too much confused with these things. It is a common parameters for an industry looking forward for it is process plants. So just for your benefit, and I just want to take asset integrity is basically asset insight, and if I can show you that what it is I'm talking about, because it is very difficult to also map. Suppose say we have an industry like power generation in you know Neyveli lignite is one example where everybody is aware of this in power generation, and there you have a different assets are involved. It is turbine, which is a key in the power generation, and then you have a steam boiler, and then you have other component associated with the power generation process. How these assets are performing well is very important for the lignite corporations to know. So that means how critical is this asset? And I'm just asking a question. And what is the history of this asset? How long this turbine was running? What is the current health? And what maintenance cost for the last 5 years we have spent? And what's going to be its life cycle for next 5 years? How much money it is going to cost for us to maintain this? And what would be the consequences of the asset failure? I mean, if it fails, so what will happen? The power generation stops, and then our, the power grid is going to go down, and the whole Tamil Nadu is connected with this is going to be seeing the darkness. What is the impact? What action should be taken now to see this continuously running? These are the questions we are going to ask for the asset integrity or asset health. So then the answers could be in a digital way. And I would say that the collect, contextualize, and analyze and visualize the data using this analytics platform, and prioritize based on the suggestion, determining which assets are most critical, and then you tag them, what operations you need to expecting, and then what kind of prescriptive actions you are going to do this. Understand the true status of each assets and the prescriptiveness needed for this, and then the continuous real-time analysis of all these things are very much important from that. So that is all provided that what we have seen in the AI suits and the platform. So like contextualizing from the various data sources, I use this contextualization in the cognitive data models, or the data models basically. How can we see the 360-degree view of this particular asset? It has got a data which is design parameters, operation parameters, computerized maintenance and management system perspective, or it could be anything. I mean, all that you need to contextualize, and you need to create a information model which is structured and layered, and you can go to the any level dice down to the any level, and you should be able to narrate that what is this for me and what kind of information I'm going to take it from this model. Analytics point of view, if you look at the plant level and the kind of actor analysis where you can see these different components, it could be a transformer, it could be control wall, could be heat exchanger or anything. I want to see the performance of its health, and then how I want to analyze for continuous health positively and inspections, and then MOC and maintenance and cost analysis, and also its predictabilities for useful lives for next 10 years or 5 years. I don't know what it is. I want to have this. I don't want to see this failing in the middle. So this is basically that I I was coming to kind of applicability of these different business needs. But then I talked about also a little bit of pre-built applications and the value applications with our AI suits. Also, I talked about industry cognitive models, where we have industry specific and also value fair specific data models, which are pre-built and available. Apart from a data scientist can also explore to build his own. So these are all the applications, and the application, if I talk about anomaly detection, it could be anything with respect to assets, where we can use the pre-built model through our AI and ML capabilities. Opportunity loss manager, it just provides whenever there is a disturbances in the plant and what kind of loss the plant is going to occur. We have a pre-built model, and then that is basically this application provides. Pipeline integrity, and it is basically for monitoring integrity and the decision support for identifying the risk and mitigating those things. And then the machine performance analysis, which also talked a little bit in assessing the performance and also health and health deteriorations, and then coming out with the prescriptiveness in that. And likewise, I can go on. I don't want to get into these applications, and you will see multiple capabilities available there. So if you look at one specific application, so exactly it is basically manifested in the solution. The anomaly detection is a one thing which I would like to a little bit explore, and I think I have still another 20 minutes. Probably I'll try to cover. Identify the what is the objectives. Basically, like I want to identify anomaly in my equipment, and I want to use the AI suite from this AI and ML capabilities, and I would like to have these alerts, and then I also would like to see that why this problem has happened and what should be the corrective actions and how this could be prevented in the future. That means that some sort of prescriptive action should be there in that. So then the applicability, if you look at a little bit, it could be a different component, like I talked about. It's a motor pump, whatever it is, and the it comprises of multiple, the structures, which is basically having different layers or different data categories, which needs to be one consolidated or formed for basic analysis. That is one thing. And the logical system defined by the system boundaries confining the different aspects of the equipment, which is what is you can talk about in the domain point of view, oil train, crude pumps, separators, or whatever it is. And I don't want to get detail into those domain aspects, but very important to see that how one can create the solution with just the configuration capabilities instead of building the model from the scratch. And you define the system and they configure the asset variables. Why it is possible? Because you have cognitive models are all already available, and then you can just needs to use them. And the defined system scoring, that you can provide the thresholds and also different expectations. That thresholds will be taken care from the scoring systems. So then when you apply these things, the anomaly detection process itself will start looking for the data which is coming in, and then it analyzes for the trained model, and then it will identify a different perspectives, including cause and effect, and then also the performance history, and also catastrophic failure possibilities predictively, and also the recommendations. If you look at in the larger perspective, the input is basically coming in a structured data, and then the processing happens using this system configuration enabled by AML models, and then you'll have the output basically providing the failure or risk scoring or alert notification, so on and so forth. And then if you look at the entire process itself, and it's basically identifying the anomaly, and it is basically provides the detections first of all, and the response time, it's basically time to failure, how much time it will take to fail, it is going to analyze these things. The risk prioritization, which is basically provide an alert type, and also impact, what impact you have in terms of severity. And then the anomalous parameters, basically what was causing this, whether it is electrical signal going from some level to another level, or some kind of catalytical component impacted the mechanics of that, don't know. That is basically providing the root cause. And then the acknowledge, user needs to accept those and acknowledge those. And then the playback and smart indicators, basically you will see some kind of dashboards, maybe I'll try to bring in from the demo, but let me see. And then the correlations, and how different parameters are correlated for this kind of failures. So then you can also see these are the dashboards basically coming from the input data, time series data, and then it is a preparation like in contextualizing and applying thresholds and determining the different threshold level, what is happening, trending of different parameters within the threshold parameters. And then this PCA percentage variations, also you can see that. And then you can also see the stable zone. If it is everything happening within this zone, it is green. And then if you look at the different overlapping zone where the yellow and red spots have started coming in, that's basically the anomalies which are detected if it is impacted by some wrongdoing with that. So these kind of analysis are possible for user to explore. So now I I don't know how much time should I stop now, or maybe I have a couple of slides where I just wanted to conclude with different applications, which I don't want to go into the details. Increase availability of asset and point. Uh,
Sir, you can proceed.
okay, ma'am. Okay, ma'am. So um, I would like to take a couple of use cases, which is basically helping you to realize that what I'm talking about when it comes to industry applications. So in this case, objective is asset managers. That means any kind of assets, and we want to manage that. We talked about a lot already in the performance and the life cycles, things like that. What is today's challenge? Only 18% of assets have an age-related failure patterns. I've installed a reactor or a pump or something else, and only they know today, as per industry experience, 18% of assets have the age-related failure patterns, but 82% of assets don't have that, and it is happens randomly. As per ARC, most random failures of asset are due to impact of related assets. That means that a reactor is connected with the pump, and the reactor with reactor is also connected with heating jackets, and basically these connected assets are creating disturbances or their variation in the parameters. So these are the challenges. How can I understand with this AI ML capabilities with this kind of analytics platform? And that solution is, now you extract the data from IT and also OT and also ET. So why this IT is basically the equipment is brought from which vendor, and what are the specification, and what are those commercial parameters, and the OT is its operational capability itself, and how that is configured, what kind of power it is energized, and how the co-connected the assets are linked, and what is that operational abilities. All that comes from OSI PI model. And I'm sure this PI model, you're all aware that I will not get into the details. And then the engineering technologies, basically it's design parameters and engineering parameters, all are consolidated into this analytics. And we are going to automate this contextualization of these IT, OT, ET data because we have that pre-built connectors of different protocols. And then we build the schematics for visual integration. That's what our digital twin will come into picture, because we have a different layers and the different type of data and different dimensions of the data which is associating for this particular asset. All that it basically manifested there. And then the model creation, once that is there, and that is basically ready for detecting the anomalies. So basically, you will see this. You are not able. Probably you may not be able to see everything very clear here, and it is basically shows that the down part shows that what is the yellow or the dark yellow things, what particular component in this assets is basically creating the problem. And then you can also see the overview that trending from the time origin, what has been happening with that. There is some disturbances, and then you can also see the digital twin of this particular equipment which are connected with a complete. It is basically a turbine schematics where the turbine itself is supported by multiple assets. One of the asset is basically having some yellow patches. That's where is the problem it is showing here, and you can relate those things. So then it is also going to be once this kind of prescriptive solutions are provided, industry experience that 50% downtime is reduced by proactive maintenance by these AI-enabled solutions. So likewise, we also have opportunity loss manager. In a way, I talked about. I don't want to go into the details, but objective is that in an industry, I want to know that if something has happened and what is the opportunity loss. And today we don't have that kind of capabilities to know that how much it is impacting on my business. As a manufacturing plant faces the multiple glitches due to complex and disconnected processes, but we don't have the real remedy why this slowdown, why it is shut down, and what kind of prescriptiveness I can come. I don't have any information or intelligence. So that solution provides. Again, you are going in IT and OT kind of the contextualized data, analyzing those and coming with the root cause analysis, and then trying to analyze that what is basically the loss, that how can I also reduce going forward. So that's basically industry experience has shown that by applying these kind of solutions, already 5 to 10% of hidden costs are removed. Similarly, 360-degree view, I talked about digital twin. We can really create in your virtual dashboard, you can see that the component is showing as you can see in physical. And then you can see all asset connected or different sensor signals are associating with equipments can be seen in a mimic or in a 360-degree representation with other parameters. But rest other things are basically what I explained in other two things. So this means what is that basically we are going to benefit? Identify the bad actors. That means that I have a equipment which has got a different components associating with this, and this is what is creating the puzzle. And then I need to take that or repair that. Then all that can I see by sitting here in my office. So finally, that what is the conclusions we are going to come to this end of this, and basically that AI suits are possible to deploy a kind of hybrid, or it is on-premise or standalone cloud capabilities, and the functionalities are very modular, and it is diverse capabilities can be applied for diversified industry applications, and you can build your own models. And then you can also use the various business specific applications for building your solutions. And then the visibility can be created using the common HMI capabilities, and you build your own visualization, whether it is you want to trend it or you want to chart it, where you want to report it and notify many things. And then also analytics provides the pre-built models and the self-service analytics capabilities one can do with a little knowledge about the data, but not necessary hi-fi data scientist. Finally, I'm coming to connect this how our operational performance management is achieved through integrated assets. sustaining their health, and then integrating the supply chain. And that is where is our analytic solutions are going to provide. And finally, the core or crux of this AI ML on our analytics platform, industrial IoT and analytics suites addresses the needs for industrial analytics. AI and machine learning aids to those, and the data driven services to connect, collect, contextualize, and then analyze for advanced analytics are a core, and that is already pre-built and provided now. And then actionable insights for improved productivity, prescriptiveness, or maybe cost analysis, the loss analysis, everything is comes from the different levels of dimensionality. And then on the right side, the reason of interest basically for the rapid data analysis. If you look at, you can always clutter out the different spots and where we need to focus on, and then advanced analytic applications and ready connector or collection adapters, data connectors, and pre-built data models like what talked about industry cognitive data models, and advanced model fabric, which is basically core of data exploration, data modeling, or data model building, and then model registering, and that provides from our fabric of that model sandbox, and the knowledge services which will help you to integrate different applications for inferring different things. Then the open standard based fully secured extendable models, because security is very important when you're connecting to the advanced systems or the legacy systems, and your connector should be able to extract the data in a more secured way, because security is very important paramount from the data extraction process. And then the domain expertise is the key, and unless until we know how, and this is not possible to build such an analytic capabilities. So from that point of view, it aids a lot of values in our applications building. This is what as I stops now. For any questions if there are, or I can interestingly show one. Sorry that. I talked about a little bit on the contextual model, and I just wanted to show that some dashboards. Um, Here is what is that how the loss analysis could be seen. Um, Basically, based on the data which is basically analyzed, and it is going to show you that uh, how this the failure happens, and how this was performing healthy over a period of time. Things are going wrong. You can see the trend here, and then below it will show the useful life cycle left for the assets, basically for the horizon of time, and how the life goes with the these assets, and the forecasting the falling possibilities also with the different data. We can forecast with this, and somewhere here it shows some disturbances are bound to happen. And then on the top, if you see this availability opportunity, you can see that 90% this equipment is available, and the loss could be 200K US and things like that. I mean, this is basically providing the very comprehensive approaches. Another thing is the risk assessment, like how risky this component is we are running with. It is going to tell you the safety, environment, and operations, and the financial standpoint, what kind of risk we see. And green shows the no risks, and yellow means you're already coming to the risk zone, and the red part shows that you're already in risk, something like that. And this is the digital twin. One of the example I would like to show. There is equipment, there is a pump, and there is some the connected hose to the some reservoir, and there is a two pipes connected here, and one pipe which is yellow has a problem. That is what the digital twin in the AI suite is telling you in your solution. Application is telling you, representing there is a problem with this asset. I've just took the part of that asset, but anyhow, you see this particular pipe is having some detachable component, and here is a wall, and here is a problem. And how it is basically building the digital twin information model in different structures, and it is exactly pinpointing that data element, and then it is basically telling you this. And another one, I'm bringing this what we've seen in the RBI, and it is basically showing the identification and the repair point of view, and it is basically like how prescriptively you need to repair it. So now this visualization, you're seeing the 360 or a 3D model where the earlier asset is basically shown the yellow part, and now it is telling you, if you look at this particular things, and it is telling this particular thing needs to be replaced, and how this needs to be replaced, and that is basically it is providing the steps, and then this is what is you need to repair by replacing something here. So these kind of possibilities are existing in this kind of um, solution offerings. So this is basically like one other example of the digital twin, and where we looked at the turbine process, and the turbine has an issue with the inlet jacket and an outlet jacket, some problem, and it is identifying the problem area pictorially, and it is a 2D model. It is not a 3D yet, but the 3D is also, I didn't get the picture. That it's basically telling you that where is the problem, and how this problem happened, like what we discussed earlier in anomaly detection, and all that is possible. I'm now stops here, and this is what is I just wanted to share with you, um, and I'm open to the questions, any comments, and
Sir, thank you for your valuable and informative session, sir.
thank you. Any questions or any comments, then probably I can take.